Chapter 13 is on water. So the first part of this chapter starts out talking about the San Francisco Bay. And the reason why the San Francisco Bay is such of interest is because it is the largest and most productive estuary on the west coast, or the Pacific coast of the United States. There are a couple cities that are surrounded by or surround the estuary. Of course, you have San Francisco, you have Oakland, you have also San Jose. There are a couple main rivers that flow into it. You've got the Sacramento River and the San Joaquin River, and these two rivers provide two-thirds of all of the drinking water for the entire state. These rivers also supply 45%. The water supplies 45% of the nation's fruits and vegetables that are grown there. So 45% of all the fruits and vegetables in the United States are grown in this area, and they get their water supply from those rivers. Well, the bay is also a concern because it is getting smaller. It is actually smaller now than it was 100 years ago. You have reduction in marshlands. And do you remember why marshes are good? Yeah, marshes reduce pollution. They also filter a lot of waste. So marshes are disappearing. And then also years of water diversion. And water diversion is where you just divert water. You send it in a different direction, or you block it to do hydroelectricity. And years of this diversion with water pollution and introducing invasive species have harmed the delta over years. From the less fresh water, we've had an increase in, let me put this up here, increase in salt water. And when you have an increase of salt water, you get what is known as saltwater intrusion. And when salt water intrudes even farther in, you can have salt water intrude into the drinking water supply. And that would then violate the Clean Water Act. So you get saltwater intrusion if you don't have as much fresh water flowing through. And because of all this, the CalFed was formed by the government as a protection. And this CalFed, what it does is it protects the water supply reliability, so it tries to prevent saltwater intrusion. Also water quality from water pollution and runoff. Levee system integrity, and levees are those walls that are put up to prevent water from flooding over into other areas. And then also ecosystem health with making sure to control invasive species and the quantities of the native species in these areas. So why do you think water is so important? Well, let's first explore the properties of water. Remember back to general biology or chemistry, I've got here a water molecule, which is composed of an oxygen and two hydrogens, and when they come together, because the water molecules are polar, right, you have a negative side because more electrons on this side, and a positive side, less electrons and more protons. You get what is known as hydrogen bonding, or this attraction because of the polar water molecules. Water is very unstable, meaning that in normal temperatures across the globe, it can be in a solid, liquid, or gas state. So quantity versus quality. 97.5% of all the water on Earth is seawater. It's H2O plus salt and other trace elements. Only 2.5% of it is fresh. And down here you can see these good examples. So this 2.5% is fresh. Of that fresh water, almost 2% of it is trapped in ice caps and glaciers. And only about 0.5 or 0.6 of that is groundwater. And then of that small percent here, half of it is in lakes. You have another portion that's in soil, rivers, and then trapped in biota, or living things. And then there's a small little sliver that's water vapor in the atmosphere. So of all the water on Earth, there's only very little water that we can actually use to drink, and that term is potable. Alright, and you'll see that in some of the videos. If you remember back to chapter 6 in the hydrologic cycle, going through those different stages as water cycles through an ecosystem. And you can go to this link here to see that water cycle again. So looking more at the water cycle here, you can see evaporation, we get condensation, precipitation, runoff, accumulation here in lakes, and then you get infiltration, alright, and it can infiltrate down to a certain point where it hits some type of layer that is impermeable, so it can't penetrate through, and usually wells dig down to this point, and this is where you have your first underground water or water table. And then if you go even below that impenetrable layer, you get what is known as aquifers, and these are confined aquifers and then unconfined aquifers.